Bismillahirrahmanirrahim. Dear students, I hope you are well and preparing for your MDCAT in a nice manner. So today we have a new test, some difficult questions and easy answers in a shortest time. A DC power supply is connected in series to a resistor R is equals to 2 ohm and a capacitor C is equals to 1.5 farad. EMF of the battery is 9 volt. Then the value of maximum charge Q naught. Q naught will be given as CV. Q is equals to CV, but here we have maximum charge. Q naught is equals to CE. So Q naught is equals to C is 1.5 multiply by this is 9. So Q naught is 13.5 coulomb. This is your first answer. Now the next one. Now how much time is required to obtain the maximum charge? We know that we have a time constant tau is equals to RC. R is how much? 2 ohm and C is 1.5 farad. So tau is equals to 3 second. The time required to maximum charge is given as T is equals to 5 tau. In this time approximately 93%, more than 93% of the battery will be charged, the plates will be charged. So let's put the values and get the result. 5 into 3, so T is equals to 15 second. So our result is Q naught is 13.5 coulomb and time required to maximum charge is 15 second. A copper wire has a length L and cross-sectional area A. Its resistance is R. We know that the formula for resistance is R is equals to rho L over A. Let this be the first case and then move further. If we halve the length, then L prime will become half L and half the diameter of wire. Now what's the relation of diameter? Area is given as pi r square and radius is the half of diameter. So when diameter is halved, so the radius will be halved. So A prime will be A pi r by 2 whole square. So this will become A prime equals to pi r square by 4. So when we take pi r square, we'll get A prime is equals to 1 over 4 A. Now we have A prime, we have L prime. What we have to find out? Then we have to find out the resistance of this wire, the new resistance of the wire. So this will be R prime. R prime equals to what? Rho L prime over A prime. L prime is half L and this is 1 over 4 A. This 4 will go up and 2 will come down. So we'll get R equals to 4L over 2A and this rho is there. It is there, rho is there. So we can check 2 on the 2, 2 to the 4. So this will be 2 rho L over A. This corresponds to the original resistance. So R now becomes equals to 2R, doubled. So the correct option is number 2. Let's move to the next one. Two electric bulbs P and Q of powers 250 watt and 1000 watt respectively. We have two bulbs. Power of the first bulb is 250 watt. The power of the second bulb is 1000 watt. So P1 is 250 watt. P2 is 1000 watt. Are connected to 110 volt power supply. So voltage of the supply is 110 volt. The ratio of currents passing through bulbs P to the current passing through bulb Q is I1 over I2. This we have to find out. Okay. So instead of going into the lengthy calculation, we can simplify it very quickly. We know that the power is given as, if I write P1, P2, power is given as IV. Which of the following refers to the DC current that does not change its intensity? So what are the options? Leakage current? No. Eddies current? No, not at all. Surge current? Not at all, because it is not changing its intensity, means it is not changing its polarity either or the frequency. It is constant. So the constant current, the answer is the constant current. DC current is a constant current. and it is also known as steady current. So the steady current is the correct option. Move to the next one. Which of the following materials have negative temperature coefficients? Immediately we must know the definition of the negative temperature coefficient, the one whose resistance decreases with the increasing temperature. So this is the property which is only associated with the semiconductors. So let's find out the pair of the semiconductor out of these four pairs. The first one, germanium and iron. Iron is a metal, not semiconductor. Reject it. This one is iron and silicon. Again, iron, cancel. This also has iron, copper, cancel. So germanium and silicon. Second option is okay.